Good morning.
Morning.
Good morning.
Morning.
Thank you so much. Okay, my name is Jinny Hoài Trâm, and it's my honor to be the MC for BUIDL Vietnam for 2 days. So, can we have a quick check-in with each other? Is this the first day you are with BUIDL Vietnam? Your first day. What about second day? Is there anybody? Like 1, 2, 3, 4, 5, 1,000 people here for 2 days with BUIDL Vietnam. Thank you very much. I'm not really good at math. Okay, so we are very happy to welcome you here. BUIDL Vietnam 2023. We call it a festival for the builders. And for the second day, we are in a very cozy space. I hope that it brings you back to the day you are in university, like Saturday, going to school, have a discussion with your friends. So for this day, we hope that the speaker here is your friend and you are their friend. So feel free to talk, to raise your question, and to make it more interactive. Okay, a quick introduction about BUIDL Vietnam. It's a festival for the builders, and for 2 days there will be presentation about technical development in crypto, and we also have the workshop. You can see it right from here. We also have a hackathon for the builders joining with us for this year challenge. So please check out our main track and also the workshop calendar so that you won't miss any activities that you are interested in. Okay, so I think that's enough for the introduction. Our guest speaker is here. It's ready to share with you for the first topic, that is harness. Sorry. For the first topic, we are welcoming a representative from Aleo. And here we have Anthony Di Prezio. Please welcome him to the stage. All right, thank you so much for being here with us. And now the stage is yours.
Thank you. Thank you very much. How's everybody doing today? We excited for the second day of BUIDL Vietnam? Yes? Come on. Are we excited? Come on, I want to hear it from people. All right, there we go. Perfect, perfect. Yeah, so thanks for the introduction. I'm really excited to be here in Vietnam. This is actually my first time in the country. It's been an amazing experience so far. And yeah, today I will be presenting Aleo, which is the project that I work at, and talking about how you can leverage the platform to build with zero knowledge. So this won't be a super technical presentation, more a high-level overview of what we're building and how you can get involved if you're interested. But just quickly before I start, so I'm Anthony Di Prezio. I am head of ecosystem growth at Aleo. I've been at the company for 2 years. I've actually worked in crypto since 2016, starting when I was an undergraduate at UC Berkeley, and have basically stayed in the industry since then. And this has probably been the most interesting project I've worked on, and I think zero knowledge has the potential to really transform this industry and the web more broadly, and that's what we want to enable with Aleo. But actually, just before I jump in, so I can understand everybody's level of understanding, how many people are familiar with zero knowledge technology? Raise your hand if anybody's familiar. Okay, only it seems like a handful of people. So maybe before I dive in, I'll just give a quick couple sentences on zero knowledge so you can get the general idea. So at a high level, what is zero knowledge? Zero knowledge is a way for you to prove some statement about something to somebody without actually having to reveal the underlying data or information about that statement. And I'll be talking about a few examples where you can actually leverage this concept in the context of Aleo, and hopefully it will make more sense. But the main takeaway here is that ZK is this cool new technology that enables privacy, and Aleo is basically allowing developers to leverage that technology. So just to jump in here, I wanted to start with sort of like a quick history lesson of this industry so you can get a better idea of like where Aleo is trying to push this concept of decentralized systems, right? So if we go all the way back, even before Bitcoin, right, people have been trying to digitize money, right? So just digitizing fiat currencies, right? And there were a few examples of that, namely things like DigiCash, Hashcash, eGold, BitGold, all these different kinds of concepts. But you know, they were all failures and didn't really amount to anything, right? We kind of stuck with our current monetary system and didn't really move to digital money. Then in 2008, you get Bitcoin, right? And I'm sure everybody in this room is familiar with Bitcoin, right? first time somebody created this decentralized store of value. What was really interesting about Bitcoin wasn't the fact that they created digital money, right? People had tried to do that before. The key innovation was actually around the crypto economic security and incentives that were developed with Bitcoin, right? So for the first time, we were actually able to create this monetary system that didn't rely on central entities or banking to actually facilitate, this digital store of value. And so that was the key innovation there with Bitcoin. And from that, you kind of see other projects start to emerge, namely Litecoin. Maybe you've heard of that project, Zcash, which actually we'll talk about a little bit in this presentation, as a huge inspiration for Aleo. Then around 2016 timeframe, you start to have folks like Vitalik and others, particularly in the Ethereum ecosystem, and others say, hey, this innovation with Bitcoin, this crypto economic incentives is really cool. How do we actually enable more, right? So they came up with this idea of having like an on-chain virtual machine, right? And in Ethereum, it's the Ethereum virtual machine. And the general idea there was, okay, we can actually take these cool incentives and do more complex, like decentralized applications instead of just having some digital store of value. And from that, you kind of get a lot of other projects. Near Protocol is actually speaking at this conference, Cosmos, Polkadot, so on and so forth. And that's kind of where we're at right now. And so now comes in Aleo. And the key thing with Aleo is that we're trying to implement this new concept called zero knowledge execution, or ZEXE for short. So Aleo was actually developed based on a research paper called ZEXE. It was co-authored by our founder, Howard Wu, and a few other professors from a number of different universities. And the general idea here is, how can we take the crypto economic incentives of Bitcoin, this concept of an on-chain virtual machine, but then add zero knowledge onto it, right? And why do we want to add zero knowledge? Because it allows you to have this layer of privacy, right? And in our opinion, in order to get mainstream adoption of this technology, you need to have privacy somewhere, right? Like, because currently in existing blockchain architectures, everything is fully public. And that kind of leads itself to some issues that might arise if you're trying to build out certain types of applications. And we'll kind of dive into what those applications are. One thing I want to point out is that Aleo is not an Ethereum killer. It's not a Bitcoin killer. We're not trying to, replace any of these other projects. We're basically trying to enable developers to build out different kinds of nuanced use cases that are not enabled by some of these other platforms. And in fact, there are some applications that are better for these platforms that maybe you wouldn't want to do on Aleo, but we do see like a huge use case area that we can kind of take advantage of. Okay, so another way to sort of visualize this is what we want to do is create like private applications, right? Which is kind of what I mentioned before. So taking the programmability of Ethereum and combining it with something like the privacy of Zcash. Zcash, just a little bit on that, if you're not familiar, they were kind of one of the first projects to really commercialize using zero knowledge. In particular, they use a construction called snarks. I won't get into all the details of that. Basically, all you need to know is it's a specific flavor of zero knowledge, right? There's many different ways to use ZK. In fact, Starkware is another project here, right? They use something called Starks. Again, won't get into the differences there, but there's many different ways you can try to leverage ZK. And they've been a huge inspiration for us. And what they essentially did was kind of make private money. So taking Bitcoin, but making it more private. So interesting concept there, but how do we actually bring that so you can create private applications? And that's essentially what we're developing. And a few other key things to highlight is that unlike some other platforms, Aleo has zero gas fees. Well, if you choose to run all your computation off-chain. So I'll explain really quickly. Basically in Aleo, one of the core primitives is that if I want to run some computation, I can do that off-chain in an off-chain environment. I generate a zero-knowledge proof, right, which is just representing some statement without revealing information about it. And then I upload the zero-knowledge proof on-chain. So any execution you do off-chain does not require gas fees, right? And you have to understand, like, why does Ethereum, why do these other platforms have gas fees? Well, it's so people can't DOS the system, which stands for denial of service attack, right? We don't want people to spam this system and like crash it, right? But since we're running computation off-chain, that's not really a concern. I will say we do have the option for you to do on-chain computation in shared state if you choose. In that case, you would have to pay an equivalent of like a gas fee, right? But you can do everything entirely off-chain, so it is possible to have zero. And then because of the off-chain computation that we're running here, you also have unlimited application runtime. This is really great because you can do much more complex kinds of applications, which, again, we think if you want to get these in production sort of use cases, the complexity is going to be huge. And that's why we're seeing all these layer 2 solutions trying to scale Ethereum, right? Because complexity is a big deal. But out of the box, like, we are scalable just in nature. So yeah, those are just some key highlights I wanted to point out. And so together with the various components we've built in our stack, you get this zero knowledge, you get this basically this way to do zero knowledge applications on the web. And so I kind of just wanted to highlight the three main actors in the Aleo ecosystem and the pieces of the stack where they are involved. So the first group of people are developers, right? So these might be people like yourself, web developers, anybody that wants to build an application on Aleo. And the way that they can actually do that is through our programming language called Leo. So we've actually developed our own programming language. It's a domain-specific language. It's a ZK compiler. It's a compiler language. And really what we've tried to do with Leo is design it in such a way that we abstract away all the complexity of building with ZK, right? So before Leo, you would have to write your own circuits. Typically, you would have to be very knowledgeable in cryptography. There was a lot of barriers to entry, whereas here, you don't really need to worry about any of that. Leo is designed similarly to languages like TypeScript or Rust, something that maybe a web developer would already be familiar with. So the barrier to entry is pretty low on that. The second group of people in the ecosystem are provers, right? So basically, the provers are individuals that take the programs that a developer wrote in Aleo and are deployed to our program registry, which I'll talk about a little bit more, and they actually run those programs. So those are the people that are running those programs, running that computation off-chain that I mentioned before. And the way that they do that is by using specialized hardware for generating zero-knowledge proofs. And we've actually developed an architecture that incentivizes provers to compete against each other to generate proofs on the network as a way to create more efficient hardware, right? Because if they're competing, then you want to create more efficient hardware to be more effective. It's kind of similar to what you would do in Bitcoin with mining, except in this system, it's not called mining, it's called proving, right? Because you're not like mining blocks, you're generating proofs instead. But it's a similar idea, and I can talk more about the mechanisms behind that. It's a proof of work-based mechanism called proof of succinct work. It's not part of consensus, it's just there as a way to incentivize these provers. And all of that is done through our virtual machine. So we have a ZK VM, not a ZK EVM, drop the E, right? We are not an EVM chain. Again, because what I mentioned before is you cannot do certain kinds of privacy applications on the EVM, for example, right? It doesn't have the opcodes that support some of the functionality you would want to have. So we've developed our own ZK VM. It's called Snark VM. Again, Snark because that's the flavor of ZK that we use. And yeah, it's just a distributed virtual machine for those zero-knowledge executions that I mentioned earlier. And then the last group are validators. So validators, these are the individuals that contribute to consensus. So again, provers don't contribute to consensus, validators do. So once the provers generate these proofs, run this computation, then it gets pushed to the validators, and the validators basically come to consensus to say okay, is this a valid proof or not? And then it gets added to the blockchain. So the mechanism that we're using for consensus is called Aleo BFT. It's actually Bullshark, which is what Aptos uses. So if people are familiar with that project, it's a similar consensus mechanism. And we're currently implementing that right now. So it's not fully live in production, but it's coming online soon. And I guess just to mention, we are currently in a test net. We have not launched mainnet. So all these concepts are currently in testing, and you can play around with them. You can run a prover. You can deploy a program if you want. Unfortunately, we pre-selected a small group of validators for the testnet, so you can't really do that. But on mainnet, you could. So yeah, that's what the validators are there for, and they're using our operating systems. We've also developed our own operating system called Snark OS. So yeah, those are kind of the three core components that we've built out. There's some more nuances to each of those, but just so you understand the high level. And this is how all those actors are involved. And this is just another way to visualize that. I think the main takeaway here is you can't have this architecture without all of these parties working in tandem, which I think is really important. Okay, and just to give another comparison, because I'm sure people are more familiar with the Ethereum ecosystem, the way you can almost think about this is developers on Aleo are just like developers on Ethereum, right? In Ethereum, I write a smart contract, I deploy that, people can use it. Same thing on Aleo, except in our architecture, we call them programs, right? I'm a developer, I write some program, people can use it. Okay, then we have the provers. I kind of just gave the overview of that. That's where kind of the ZK piece is coming in. In Ethereum, the way people are using ZK is through the concept of rollups, right? So I guess you could kind of like match those. Again, provers are effectively doing what rollups would be doing on Ethereum, for example, but with the benefit of us using it for its privacy-preserving properties and not just scalability. So Aleo does not have a layer 2 architecture. It's a layer 1 blockchain, but all of the benefits you get from L2s on Ethereum is already natively baked into this architecture. And then the last piece, so Ethereum no longer uses miners, right? They converted to proof of stake, but so they have a validator set. We also have a validator set, functions the same way, right? Like validators on Ethereum are coming to consensus about the canonical chain. The validators on Aleo are coming to consensus about the canonical chain, right? I think the main difference probably is around like the provers and like rollups or how people are using ZK. Cool. And then, yeah, one thing I wanted to point out here is that what the cool thing at a high level, the cool thing about Leo, our programming language, is that what it's doing is it's taking really complex math and cryptography through like proof generation, right? And actually converting it into some sort of code that your computer can understand. So this program evaluation. And this is kind of like a new interesting paradigm that we've really helped to spearhead. And the Zexy white paper, like since we launched Deploy and Execute, it's like the first time you can actually do something like this. So the basic example I gave here is like, let's say I want to prove that I know the sum of two numbers. So there's variable A and variable B, and it equals some private variable C. What I can do is I can define in a Leo program what the public and private variables would be. And then I basically, what would happen is that program gets compiled to an intermediate representation called Aleo instructions, which it's an assembly-like language. You can also build in it if you want. And then that goes directly to R1CS and is processed by our virtual machine. And again, at a very high level, what's happening here is we're taking that complex proof generation, and that's usually in the form of math and cryptography, and converting it to computer-readable code. So you can actually use it in an application. Because again, like before this, you'd actually have to write the circuits yourself, which is like really, really complicated. So all of that is abstracted away. Okay, so yeah, I'm just gonna go through like 3 quick steps. You understand like what it requires to deploy a program and use it on Aleo, and just show you how easy it can be. So deploying an Aleo program on chain, right? So this would be for developers. So you have your deployment, your transaction that you wanna add. Basically, the validators will add it to something called a program registry. And I really just want to highlight the program registry really quickly. So basically, what the program registry is, it's like a namespace. You could think of it, where basically all programs deployed on Aleo can be found. And so the cool thing about the program registry is that if I'm generating some zero knowledge proof for some particular program, right? The zero knowledge proof itself does not reveal any information about the transaction. So it's really important that we know what program it's actually running through, and anybody can publicly see that on this program registry. So if you go to a block explorer on Aleo, for example, you can actually, search a tab and find every program that's been deployed on the network. And one other thing I'll say about the program registry, and that's unique about Aleo, is that we're a private by default platform. So when you write a program in Aleo, what it means is by default, everything is fully private. But you as an application developer have the option to decide what you want private, what you want public, set all the parameters, that sort of thing. And again, when you publish it to the program registry, this is public for everybody to see. So people can see exactly how your program is running. And this is really good for meeting regulatory compliance, right? So a lot of governments are trying to figure out regulation for crypto more broadly on these architectures, and especially when we're talking about privacy projects, it's even more relevant because the problem is that when you talk about privacy, people immediately think money laundering, bad actors, all these things, but that's really not the case. Like, we're actually enabling people more. Like, we're actually providing more security. And I'll give like an example. So, like, let's say I want to launch some program for like a private USD-backed stablecoin or something like that. Okay, there's definitely going to be like regulation people want to have. The nice thing is we can go to a government, we can work with other partners to establish, okay, what are the requirements, what are the regulations, and we can custom design a program for that use case. And we can make it so that, okay, if I want access to this private USD-backed stablecoin, I run through this particular program, which already meets all of the regulatory requirements that have been defined, right? Because again, we can decide what's public, what's not. If there needs to be some option for a security researcher to selectively reveal a piece of information, assuming it, meets some requirements, like that can be baked in, right? So you have a lot of optionality, and that's what we want to really enable for developers. So anyway, that's a high level of kind of like writing your program, deploying it to this registry, and kind of the benefits of the registry, and just building an Aleo. And then, the validators add that, and then you have, your program added. And then again, another key piece here is the execution of programs off-chain. So again, this is done by the provers. Here I use the word caller, making a request. So you yourself can be a prover, right? So if I want to run some program or generate a proof for a particular application, I can do that myself if I have the relevant hardware. So in that case, this caller piece wouldn't actually exist. I would just be the prover myself. But for 90% of people, they're probably not going to have the hardware to generate zero-knowledge proofs or run this computation themselves. So what they can do is they can actually act as a caller and outsource the proof generation to a prover on the network, right? So the general idea there is I go to a prover, I say, oh, maybe I need a zero-knowledge proof generated for my digital passport or something. Maybe there's a program that enables you to do that. I outsource that to a prover, they generate it for me, and then once it gets added to the chain, I have access to the keys, the view keys, that allow me to present that to like a regulatory authority. So maybe I fly into Ho Chi Minh next time, I need to validate myself, I just go to the blockchain, I give them a view key, they can see that information that's already been recorded on the chain as a zero-knowledge proof, and they can validate my identity. And we call that proofs as a service. So proofs as a service will probably be like a really interesting market. Because if you assume that there's going to be demand for this outsourced computation, right? Because you think people are going to build like really complex stuff on Aleo, then basically, you'll be able to access this marketplace where you can, purchase like any outsourced computation that you need. And then the last step is finalizing the program state on chain. So again, this is where the validators come in. So once that program is run and executed, then you have the validators like actually add that to the chain. They do that through our consensus mechanism, and all that data becomes encrypted as a zero-knowledge proof. So yeah. So that's the very high level of like Aleo, how it works, how you can get involved. And so now what I want to talk about for a bit are just like use cases, because I think that's probably the most interesting for people at this conference. So the first one more generally is just zero knowledge decentralized finance, which I like to call ZFi. I think that's a cool term. So yeah, some examples I put here. So zero knowledge token swap. So imagine having like a decentralized exchange with the ability to reduce, not completely eliminate, right? Nobody's come up with an architecture that actually allows you to completely eliminate like front running in MEV, but reduce front running in MEV, which I think, we can have a debate about how much MEV you need to have in a system and all that sort of thing, but you potentially have the option to do that. Another one is verifiable oracles. So if people are familiar with like oracle networks, right? These are ways to attest off-chain data, and a lot of systems use them currently. But with us, like we can do like a ZK oracle, so we can attest to that off-chain data, but like having it be private. And then cross-chain routing. So that's another interesting opportunity to leverage zero-knowledge proofs. So having private settlement layer on multiple ecosystems. And then a few others. So outside of DeFi, zero-knowledge gaming is a really big one. I could go into an entire presentation on the gaming pitch, but the high level is 95% of games are imperfect information games. What does that mean? It means one player knows information that the other player doesn't, and vice versa. If I want to decentralize a game and put that on a blockchain, all the information is public, right? Because what we talked about before, there's no concept of privacy on these architectures, right? And again, all these other solutions are using ZK just to scale the games, but they're not addressing the issue of like private state, right? But with ZK, what I can do is say like, okay, well, we can decentralize the game, but we can still maintain privacy. Just to give one very easy example, let's say I'm playing poker, right? And we need to determine who won the hand. Normally everybody reveals it, the whole table sees, and then we know the winner. But imagine in this case, we could actually determine who the winner was. Nobody had to reveal their hand, and nobody could see what their hand was. Did they have a royal flush? Like, were they bluffing? We don't know. We just know that you won that hand. And that also changes the entire mental dynamics of how you play poker, because now I can't, like, if you're really good at math, or like a good poker player, now I don't know what's left in the deck, right? Like, I have no context. So it basically changes your entire strategy. So on the one hand, you can change how a game's actually played, and it's also a requirement. Right? If I'm going to decentralize a game, I need privacy, or it's like ruined. So, and we think ZK is the best option for that now. There's fully homomorphic encryption, there's commit and reveal schemes, there's trusted execution environments, but they all have other trade-offs, which we won't go into. But ZK is probably a good solution, and we can let you start building with it. Okay, another one that's really popular right now is privacy-preserving machine learning. So the idea here is like, if I want to prove that the output of some machine learning algorithm is correct without having to rerun the algorithm myself or knowing the data set, I can do that with zero knowledge. So a practical example, I love ChatGPT. I use it every day at work now. It's changed my life. But how do I know that ChatGPT is giving me a correct answer? I don't. I'm just trusting it blindly. Right? I don't have the algorithm that's proprietary to OpenAI. So is the data set. It took them years to build that data set. And I understand why they want it to be proprietary. But with zero knowledge, basically what we can say is, oh yeah, this answer that ChatGPT gave me, I validated that's true through zero knowledge cryptography, using a zero knowledge proof, and I didn't have to run the algorithm or know the inputs. And that has wide-reaching implications for a lot of different kind of nuanced use cases. And I think it's going to be like really important, especially when governments start to come in with regulation around AI. Like, we're already starting to see it happen, and there's good cause for concern around that. And then another one is zero knowledge authentication, so like identity and authentication. So the digital passport, zero knowledge credentials, that's the most common one, right? Like, I want to prove that I am who I say I am without having to reveal like my address or like specific details about myself. Another interesting one is like maybe people are familiar with the concept of OAuth. Right, when I log into websites, think like ZK auth. So the general idea is like I can use a zero knowledge proof to prove that I'm the owner of this account and I can log in. And this is great because I don't have to do single sign-on and give all my data and information to like these centralized authorities, or I don't have to enter a username or password that could potentially be corrupted if somebody breaches a database, right? Like in this case, if somebody were to breach a database, so to speak, the only information they would be getting is a bunch of zero knowledge proofs that don't actually give them any information about like logging into the person's account. So that's like a really good one. And then the last one that I didn't put on here is like voting and governance. So like we have a grantee that's building a private multi-sig on Aleo right now for like that could be used for like DAOs to do like private voting, for example. So there's like a lot of interesting things around that. Cool. So some of you might be wondering how you can get involved, right? So currently, we have a developer grants program for builders. So if you're somebody that maybe wants to build one of these interesting use cases that I talked about, or something entirely different, right? There's tons of use cases that maybe we haven't even thought of, right? Like the way I like to think about this is working on the internet in the 70s, right? Like that's the level that we're at. And if I told somebody in the 70s, like, hey, I want to launch a social media platform, they'd be like, what is that, right? Like that's where we're at right now. So there could be really interesting business models and opportunities that we just haven't discovered. So if you want to build, we have grants. If you are a security researcher or a white hat hacker, we have a bug bounty program for our operating system and VM. So we're really looking for vulnerabilities in our core protocol. And yeah, we're focusing on that because we're in testnet and we want to find those core vulnerabilities before mainnet launch. So if you're interested, we have a program on HackerOne and BugCrowd. And then the last one is we have incentives for deployed programs on testnet 3. I think we're actually launching that today. It was delayed by 1 day because, yeah, we needed a green light from the engineers. But long story short, for deployed programs on the testnet, basically we have a bunch of testnet credits that are available. It's kind of like a hackathon. You can think about it, right? You can compete, you deploy a program, and then when the deadline's over, we're going to actually like judge them, and the top winners will receive Aleo credits. One complaint people have said to me is, oh, what if I don't land in the top 10 or whatever to receive rewards? I would still encourage you to participate. If you build something that's dope, I'm going to look at it, and I will reach out to you. There will be other ways for you to get involved in the ecosystem. Again, think about it like going to a hackathon, meeting people, experimenting with the tech, right? Trust me, we want builders, and there will be opportunities. So don't worry if you don't think you'll win first place or anything like that. So for information, just go to our blog. There's individual blog posts on each of these, has all the details that you need. Here's some additional resources, maybe if you want to take a picture. I should have a better way to present this, maybe with a QR code next time, but here they are. This last one is a little more obscure. So this is an awesome Aleo GitHub repo from our co-founder Howard Wu. This has some really cool applications that have already been built on Aleo. We're relaunching our website next month, so that'll be on there, but for now, that's just where it's located. Definitely take a look at that. And yeah, so that's it for my presentation. We have an event later tonight. If you're interested in joining that, scan this QR code. It's at a brewery nearby here. We'll be, just talking about Aleo, hanging out. So yeah, if you want to come, please feel free. But yeah, really appreciate you for having me today. Very excited to be in Vietnam. And if you're somebody that's interested in Aleo, definitely reach out to me. Would love to talk to you further. So with that, yeah, thank you so much.
Thank you so much, Anthony. Thank you. So thank you so much for putting everything together into a very insightful and informative presentation. I see a lot of people here like keep nodding their heads, like agreeing with you. Thank you. Thank you so much. And yeah, we also have the information about the event hosting by Aleo tonight. So hope that you can check out.